To solve a Leetcode problem 85, maximal rectangle. So for this problem, we are giving a row times columns matrix, and it's going to be a binary matrix, and inside it's going to be just characters like 1 and 0. And we want to find the largest rectangle containing any ones and return its area. So according to the first drawing, we can say this is going to be a rectangle at the left side, and the area is going to be 4. And here, this is another rectangle, so the area is going to be 6, so we're going to return the maximum area. You might think about the brute force. So the brute force's idea is that we're going to just loop through the row and column, and we just check if we can find a maximum rectangle. But definitely it's going to be time limit exceeded. Although the row and column is only 20. So on the 200, if it is 20, definitely we can use brute force. But it is 200, definitely we cannot. Because if we use brute force, we're gonna check each row and each column, and for each row and each column, we have to check the areas. So for example, if we check this one, if we check this cell, and we need to check all the possible cells. So how many of them? So it's going to be 200 to the power of 4. Definitely it's going to be time limit exceeded. So for each of the cell, we're going to expand and expand until we find the maximum one. Definitely it's going to be time limit exceeded. So now we're going to use another idea. It is a monotonic stack. So the idea is similar as Leetcode problem 84. Largest rectangle in histogram. So in histogram, it means it is just give us a H array. Inside the H array, we can find the maximum. Rectangle. And for this problem, we're gonna use a monotonic stack to solve it. And here we're gonna use the similar idea to solve it for Leetcode problem 85. So the idea is that we're going to use the brute force to loop through the row and column one cell by another cell. But while we loop through the column, we're going to turn this matrix into a H array. So if we are having a H array, let me try to use another color. If we have a H array, definitely from some areas, it's going to be something like this. It might be monotonic increasing. So for example, it's going to be like this, and maybe this is a higher, maybe this is a 1, and this is a 2. We can turn the matrix into a H array. So this is our first. We can use the first row as a H array, and then we're gonna accumulate it to the second row. And for the second row, this is gonna be 2, and this 0, this is a 2, and this is 1 1 for this H array. So maybe for the next one, it is a 3. So this is okay for us. If it is a monotonic increasing, everything should be okay. But what if we have a rectangle with here, the height is 1? If this height is 1, we're gonna pop it out of the stack. So if we pop this 3, this one out of the stack, we're gonna get an area which is 3. And now we're gonna pop this one out of the stack. If we pop out this one out of the stack, so the distance from here, this is I, and this is J. The distance from here to here, it's going to be 2. 2 times 2, it's going to be 4. 4 is bigger, so 4 is going to be our final result. Why? Because if it is monotonic increasing, because this one has already been popped out. So if we want to pop out this one, something in between must be bigger than this one, because it is monotonic increasing. So this is why we're gonna use 2 times this 2, get an area which is 4. 4 gonna be the maximum. So we're gonna pop everything like this, or we can just continue pop out this one. But this is just according to our rules. If we cannot pop out because they are equal, but we're gonna prepare another one. This is gonna be 0. We're gonna put a 0 at the end of the head array, and then we can pop this one, and we can we can pop everything out of the heat array. Yeah, out of the stack. We can pop everything out of the stack, and then for these areas, it's gonna be 4, and this is also 4. So this is gonna be the maximum area. So now let's just use this idea to solve the problem. So we're gonna prepare row and column. It's gonna be length of the matrix and length of the matrix 0. Now I wanna loop through the matrix, but before that I want to prepare a final result. It's gonna be 0. So this is gonna be our final answer. Now I want to loop through the array. Yeah, but before that, let me just define a function. So this function is for calculating the maximum area. This is going to be a monotonic stack function. Yeah, and inside it's going to be the heat array. Here I will give a pass because I will use it later. So for R in range capital R and for C in range capital C, we just want to check if this R more than 0. This means it's going to be the second row, and the matrix RC, if it is also more than 0. So this means we need to accumulate it. Yeah, so for example here it's going to be 1, 1, 1, and it's going to be 3, here it's going to be 4, but for here this is 1, but for here it's going to be 0. Because it is not 1, we don't need to accumulate. If it is 1, definitely we want to accumulate it here. This is how we're going to calculate the heat array. Yeah. So now, this means we need to accumulate. So matrix RC gonna plus equal to a matrix R and R plus 1 and C. Now we need to update the final result, and we're gonna update it from here. Yeah, because from here we calculated each of the column, and each of the column is updated, and we get the heat array, and the heat array gonna be the result gonna be the function of the matrix matrix R. Yeah, because for this row it's gonna be our final heat array, and we're gonna use the heat array to solve the problem. Yeah. Now let me just print out what happens for us. Let me just print out the heat array. Let's just have a check, and let me give a random return, maybe 0. Yeah. Now let me just run it and have a basic check. This is not okay because I think it's going to be integers 0 and 1. Actually it is not. Yeah, because currently it is a string. We need to turn the string into integers. So for the matrix it's going to be, yeah, let me just use map integer of item for each of the row. So for item in the matrix. Now we turn this matrix for each of the row. We turn the characters to integers. Now we can calculate it. Now let's just check the. Oh, why there is a map object is not subscribable? Yeah, it is not subscribable. This means we cannot use index. We have to use a list. So let me just use a list of the map. Now we can use index. Yeah. Now let's just check what is in between. So this is the output. This is 1 0. This is 1 0 1 0 0. It is okay. And for the second row, we've already calculated. It becomes a 2. This is the heat array. This is exactly what we are calculating. So it is a 2 0 2 1 1. And then for the third row, it's accumulated to 3 1 3 2 2. And for the fourth, so it's going to be 4, here going to be 0 because this is 0, and this is going to be 0, and this is a 3 because 1 1 1 it's a 3, and this is a 0. Yeah. Now we finished the calculating of the heat array. What's left behind is how we're going to use the monotonic stack to solve this heat array, to calculate the area. Yeah, so it's going to be exactly like the Leetcode problem 84. So instead of copying the code directly, I want to write it because I still want to explain it why we're going to use a monotonic stack to solve the problem. So for the final result, it's going to be the final area, and we need to prepare a stack, and the heaps array going to be updated. The final result is going to be 0 from the beginning, and inside of the stack I'm going to give a -1. Because this is just easy for the calculation. So for example, this is a 1, the height, and this is 2, and from here inside of the heaps array we're going to keep a 0. Now we need to pop it out, but here inside of the stack we need to give a -1 because we're going to use this -1 to calculate the final answer. So for example, -1 is inside of the stack. Yeah. Now what is for our heaps array? Definitely we're gonna check the index I, and we're gonna use this index I minus the stack -1 to get the distance. Yes. So let me just explain it. So here, from the stack, we're going to have a -1, and then because this is a monotonic increasing, we're going to put this is the index 0, this is index 1 for the heaps array, and we're going to put 0 and 1 at the inside. Yeah, and finally we're going to have an index 2. Yeah. Now we just want to pop it out. So I gonna equal to index 2, and the value is 0 because this is just the heaps array. Now we need to pop this out, and it's gonna be stack -1. So it's gonna be this one minus the stack -1 times the height, which is going to be 2, and if we pop this out, this is going to be I minus 0 times 1, it's going to be 2. Yeah, let me just calculate it. So for the heaps array, it's going to be height plus a 0. Yeah, for this 0 is just that if this is monotonic increasing, it might have the maximum area. I need to put a 0 at the end in order to pop out all those areas. Yeah, let me just continue to calculate. If I find something wrong, I'm gonna explain it. Yeah, so inside of the stack, I'm gonna give a -1. This is gonna be just easy for the calculation. So for I8 in enumerate, 8 is just the height inside of the heaps array, while length of the stack, because I put a value inside of the stack -1, so while it is more than 1, and it is a monotonic increasing, and and our current height is less than the height of a stack -1. So this means that it didn't meet the rules. This is increasing, this is increasing, but here this is a 0. So what's going to happen for this one? Definitely we want to pop it out. Yeah. Now we want to pop it out. It's going to be an index j. It's going to be equal to stack.pop. And from here we can calculate the maximum area. So yeah, let's just check the distance first. So the distance is going to be I minus stack -1 plus 1 times height. Yeah, let me just think about it. So Yeah, it's gonna be this height z, definitely. It is not the height, it is h j. And finally we're gonna return the result. But if we go out of the while loop, definitely we want to put something inside the stack. So we're gonna append the index I. Yeah. Now what's left behind is this calculation. Is this okay? Let me think about it. So, for example, this is I gonna be 2. Minus the stack negative 1, 2 minus 1, yeah, I'm not sure. Let me just run it to check if it works. Oh, it didn't. Maybe I don't need to plus 1. Let me just have a check. No. This is we pop out. This is the index, and this is the result. I think it's going to be I minus j. Why it is the stack negative 1? I minus j. Yeah, let me use I minus j plus a 1. No. Yeah, I think I need to keep this I, and this I is useful for the calculation. I, and if I pop this out, I need to use this height, and then here is I, minus yeah, because this one has been popped out, so it's going to be I minus j. Yeah, I don't know. Let me just try. Minus stack negative 1 plus a 1. Yeah, let me just check what happens. It's going to be I minus the stack minus 1 minus a 1. Oh, this is something I did wrong. Let me try. Yeah, I did some calculations, and my calculations is wrong. Let me think about it. So from the beginning, I'm gonna check each of the index I. Yeah, so this is 1. I will put 0 inside of the stack, because from the beginning there's a negative 1. So I put a negative 1, 0, and 1 inside of the stack because it is a monotonic increasing. This is 1 and 2. Yeah. Now I have another value inside of the Hits array, which is 0. So for this 0, if it didn't meet the conditions, because this 0 is less than 2, so this means I need to pop it out. So this is going to be j. I pop it out. So j gonna equal to 1, and I can calculate the areas. Yeah. So the maximum area going to be I2 minus, instead of a minus this j, I need to minus the stack minus 1. Actually, it is the stack minus 1 going to be 0. So 2 minus 0 is going to be 2. Yeah, but we still need to minus another 1. Then it becomes 1. This 2 minus stack minus 1, because this one we've already popped out. Yeah, but if we popped out, how can we use the popped out result for our calculation? Yeah, we cannot use it. So we're going to use the next value, which is going to be stack -1. This means inside the stack, there's going to always be a value -1. So we're going to use this -1. Because we popped out one value, we cannot use it, so we need to minus another one. So it means minus a -1. So minus a 1. Yeah. Now we did a calculation, and the Hits is 2. So this area is going to be 2, and this one is popped out, and this one is popped out. Yeah. Now we're going to continue. So this is 0 going to be popped out, and we're going to continue to calculate. So I is still going to be 2, and the stack -1 going to be a -1. 2 minus a -1, and we still need to minus 1, because we still we still have a much longer distance. We need to minus this one. Now 3 minus 1 gonna becomes 2. Yeah, 2 gonna be the area, because inside of the stack we prepared a -1. So because of that, we need to minus this one. Instead of using this j for the calculation, we need to use a as I explained earlier, this didn't work. We have to use the stack -1 and minus a 1. Yeah, I think that's all about it. Let me just submit it to check if it works. Yeah, maybe I didn't explain these areas clearly, so I still need more time to understand why we have to use this kind of formula to calculate the distance. Yeah, basically I think that's all about it. Thanks for watching. See you next time.